Imagine floating in the infinity of space, where our sun is just visible. In this remote corner of the world lies the planet that was once known as the ninth planet in the solar system, now reformed and shrouded in mystery. This is Pluto, a celestial body that continues to amaze scientists and astronomers. Our journey begins with the New Horizons spacecraft, an amazing space probe of human intelligence, sent to discover the secrets of this mysterious dwarf planet. Join us as we walk through the known planets to discover the amazing sights and mysteries of Pluto. Extended contents at 1,475 miles in diameter. Pluto is not one of the most impressive objects in the celestial sphere. However, this famous dwarf planet is not without spectacular sights that will amaze experts and the public alike. To take a closer look at the oldest member of our planetary system, NASA sent the New Horizons probe to the planet Pluto a few years ago. The unmanned spacecraft didn't reach the Kuiper Belt object until 2015, but the mission produced high-resolution images of the tiny celestial object we want to show you today. Will you join us on our journey into the world's greatest mysteries? So remember to subscribe to our channel and click the bell so you don't miss our future videos. Just let us know that you like the content of our posts and like it. It's August 24th, 2006, and Pluto has been stripped of its status as a planet. More than 70 years since the celestial body was first discovered, Pluto has become a powerful member of our planetary system. However, this changed when the original concept of the planet was redefined. Prior to this scientific discovery, many other objects had been discovered in the Kuiper Belt, some as large as Pluto. To prevent the number of known planets in the universe from jumping to unmanageable numbers, a new dwarf planet class was introduced, now classified as Pluto. A celestial body orbits the Sun at an average distance of about 4 billion miles. Due to its unusual orbit, this dwarf planet takes 248 years to completely orbit our host star. The great distance between the Sun and Pluto creates a freezing temperature that dominates the celestial body. In fact, Pluto's thermometer does not rise above 360 degrees Fahrenheit. At about 6.8 million square kilometers, Pluto's surface is about the size of the continent of South America. This dwarf world is 70% rock and 30% water ice. We currently know that Pluto has at least 5 natural satellites. The largest and most famous variable is the moon Charon. Discovered in 1978, this satellite is about 750 miles in diameter. Therefore, Charon is more than half the size of Pluto itself. Because of this amazing size ratio, it is called the Pluto-Charon binary system. Unlike the Earth-Moon system, the center of gravity around which the two celestial bodies revolve is not in the dwarf world, but outside Pluto. Thanks to the many images taken by New Horizons during its visit to Pluto, we can see the celestial surface in more detail than ever before. This image, showing the dwarf planet in all its glory, was taken by the spacecraft from 22,000 miles away. This image is corrected so that we see it in the natural colors that the human eye sees when looking directly at a celestial body. What strikes us when we see this amazing image is that Pluto's exterior is decorated by small planets. This phenomenon means that the surface of the dwarf world has been renewed in thousands of years. It seems that Pluto may not have escaped galactic collisions. As a result, natural processes must continue to work on the small body of the sky, and then all the collision marks will be covered. By the way, on our home planet meteorites look similar. Here, the flow of wind, water circulation and vegetation remove the holes in the galaxy from the Earth. Pluto's surface can also be seen to be divided into very bright and very dark regions. In fact, a dwarf planet exhibits the second highest brightness contrast known in the universe. Only on Saturn's moon, Iaptis, are surface differences visible. Pluto's large icy region, named Sputnik Planitia, is named after the satellite of that name, which was the first human-made object to leave Earth. Because the brezone has no impact marks, some experts believe that the plane was formed less than 100 million years ago. This process of land change may continue to this day. At first glance, the ice surface looks like a frozen dirt floor. The visible depressions in the ground, which we can clearly see in the detailed picture, may be the result of the influence of the wind. The images from Sputnik Planitia showing ice on the surface of Pluto are very interesting. The flat surface of the so-called Sputnik Planitia runs into an impressive chain of mountains, whose size is nothing to be ashamed of in comparison with the mountains of our country. Among the impressive elevations on Pluto are the nearly 11,500-foot Mount Norgay and Mount Hillary, which run along the western edge of Sputnik Planitia and tower nearly 5,000 feet above their surroundings. Most of the time, the formations are not just rocks, but liquid ice. At the freezing point common on dwarf planets, water ice hardens into rock. How these icy peaks formed on a celestial body is still a mystery to scientists. In particular, the fact that Pluto is not under the influence of a larger celestial body that can change the crust of the dwarf planet, is a big question mark for experts. This high-resolution image of Pluto's natural surface structures shows what the dwarf planet's surface looks like. At the core of this color-enhanced mosaic, we see a nearly 50-mile-wide landmass that stretches from the edge of the so-called Badlands to the icy regions of the dwarf world. To the right of this amazing image we see the dark heights known as the Cthulhu Macula. What immediately catches our eye when we look at this picture is the dark red color of the area in question. Experts believe that this color is created by tulin. It is a combination of organic molecules such as hydrogen, carbon and nitrogen. This compound is said to be abundant on Pluto, giving the dwarf planet its reddish-brown appearance. The Cthulhu Macula, meanwhile, rises 1.5 miles above the rest of the tower's terrain. The number of connecting holes indicates the location and is clearly visible. The structures are 5 to 8 miles wide and 1.5 miles deep. Pluto's atmosphere is very thin. The protective thin shell that surrounds a celestial body is mostly nitrogen. All that remains is carbon monoxide and a small amount of methane. Thanks to data collected by NASA's New Horizons spacecraft during its mission, we know that Pluto's atmosphere is 1,000 miles above the dwarf world's surface. Carbon monoxide, on the other hand, has an internal temperature of -364 degrees Fahrenheit. This is also similar to the temperature of the Earth. However, the deepest layers of the natural protective crust are much warmer than -292 degrees Fahrenheit. Experts believe that the lower surface temperature is due to the evaporation of methane, which comes from a solid state into the atmosphere. Looking at Pluto's North Pole, we once again understand the geological diversity that governs this small celestial body. The Arctic region is broken by long trenches. The largest of these natural landforms has a maximum width of 47 miles. However, the valleys near this rift structure are about 6 miles wide. The dwarf planet's canyons appear to be older than the canyon systems found elsewhere on Pluto. Scientists note that the existence of polar ice caps is a major factor in the early history of the celestial world. An unmapped view of the canyon system reveals an area known as the Tombaugh area. Scientists still do not know the origin of these many indentations on the surface. Many experts believe that these mysterious depressions were created by a connection between glacial infiltration and natural evaporation. Since the area in question has very few collision signs, it is reasonable to conclude that it was a short time earlier than the formation of the land. Individual craters are reportedly hundreds of feet wide and extend several feet into the ground. The arrangement of many structures allows scientists to make important conclusions about the exchange of nitrogen between the surface of the dwarf planet and the atmosphere. Dive deep into Pluto's mysteries. New Horizons' mission to Pluto is more than just a space tour. It's a journey back in time, allowing us to see the dwarf world as it evolved over billions of years. The spacecraft's detailed images have opened a window into Pluto's past and revealed clues about the processes that shaped its surface. As we delve deeper into the mysteries of Pluto, each aspect tells a story, and each aspect tells a chapter of Earth's history. One of the most beautiful features of Pluto's surface is its youthful appearance. The absence of holes indicates that the surface is constantly being renewed. It's also likely that cold volcanoes, liquid ice, or other non-volatile matter, rather than molten rock, melted and flowed to the surface. These volcanic crystallization processes may be responsible for the flat plains and the modern appearance of Sputnik Planitia. Pluto's mountains, like the Rockies on Earth, are also mysterious. These mountains are made of solid water ice, which is hard as rock due to extreme cold. The forces that created these mountains are not fully understood. Unlike Earth, Pluto does not have tectonic activity driven by a molten core. Theories suggest that these ice sheets were pushed down by the downward movement of nitrogen dioxide, but this is still a matter of opinion. Pluto's atmosphere, thin and thin, is a sign of energetic activity on Earth. The layers of fog seen by New Horizons represent complex interactions between the surface and the atmosphere. As the dwarf planet moves closer to the Sun in its orbit, the ice on the surface heats up slightly and turns into gas, creating a temporary atmosphere. As Pluto moves away from the Sun, these gases dry out on the surface, a process that takes centuries. The legacy of New Horizons' flyby of Pluto has revolutionized our understanding of this distant planet. Before this mission, Pluto was just a speck in our eyes, a speck on the edge of the solar system. We now have maps of the surface that show the complex and diverse landscape that rivals the inner planets. The data collected by New Horizons will continue to be analyzed for years to come, providing new insights into the geology, atmosphere and potential for future discoveries of Pluto and other planets. Kuiper Belt. This mission also raised new questions. For example, what energy source drives the terrestrial activity on Pluto? How are the different functions and dynamics of the interactions between the surface and the air created? What can Pluto teach us about the other icy bodies that inhabit the outer reaches of our solar system? The future of Pluto exploration. While New Horizons provided much information, it also revealed much more to learn. Future missions to Pluto may include probes that can map the surface for more information.